Hi, this is Glenn Burden at the Maker Hive, and today I'm going to talk to you about how to set up a printer profile on the FastBot 3D BBP1S 3D printer controller. And this setup will be for a Delta style printer. The Cartesians and the Core XY is very similar, but this one I'm going to focus specifically for the Delta. After connecting your USB, the first time you connect, you're going to get a screen asking you for a username and password. You'll have to set that up before you can get into the Octoprint. Once you're connected, you have to log in with your username and password that you just set up. After that, it should remember that, and you won't have to do it again unless you log out. But once you're logged in, you should have this screen that you see here in front of you. You simply click Settings, and you'll get your Octoprint settings page. In your printer profiles, you'll have a default already there. I'd suggest just altering that one rather than adding one, but if you want to add, you can click Add Profile. To edit the existing ones, simply click the pencil icon here, and you'll get your Edit Printer Profile. You can set your name, the identifier, this is default. Your model of your printer if you want to enter anything there. You can set your color, and then you need to select your machine type. It's going to be either a Cartesian, which is an XYZ, a Delta, or a Core XY. My particular printer is a Delta, and you can select, you see the options change depending on what you select. Yeah, the first thing you see for the Delta setup is the diagonal rod length. This is the actual length of the arm from the trucks to the platform, center to center. So if you're using ball cup, for example, connection on your arms, it'd be from the center of that ball to the truck to the center of the ball that's attached to the platform. Next, you need to know your print radius, which is the actual radius of the printer. After that, you have available print radius, which is a maximum radius you want your printer to print at, so that tells the firmware not to print outside that radius. The Z home position is the height of your printer from the nozzle to the build plate, so you want to measure that pretty accurately. I suggest you do a search for segments per second Delta and learn a little bit about it. Basically, this is how smooth your prints are on the edges. More importantly, a straight edge. It's millions of calculations per second, and this tells it how smooth that straight line is. Next, we have end stops adjustments, radius adjustments, and diagonal rod adjustments, and these are important to get your printer printing flat as possible. It can compensate for things that aren't quite aligned right or just aren't quite square, so you'll need to adjust these probably to get a nice flat print. Coming down, we have heated bed. You check that if you have a heated bed, leave it open if you don't. This will also display the temperature of your heated bed, even if you're controlling the heated bed by a different thermostat. You can use this to monitor the heat in Octoprint. You then set your maximum heat PWM values. The values range anywhere from 10 to 99. 85 seems to work good for the hot end. Your max dangerous temperature, you want to set these for temperature values that the hottest you want to get before it damages your thermistor, your thermocoupler, or starts to melt things down. So if you're using probably like an E3D light print nozzle, you may want to set this down to around 250, 240. The axis max speed, millimeters per second. Deltas can move pretty quickly, so I bumped mine up to 9,000. That might be a little extreme, but I don't seem to have a problem with printing or any skips. If your motors move backwards, you can invert the control here to make them move the correct direction, or you can just shut your machine down, flip your wires on your connection to the motor, and that'll do the same thing. You can specify your nozzle diameter here. I'm not real sure why this is here, as it should be in your slicing parameters. The extended interface here sets up the operation of the extra stepper driver. If you have a dual extruder, you'd want to select dual extruder, and then obviously set number of extruders to 2. Motor steps per unit is steps per revolution. Enter in your motor steps per millimeter in here. Mine was calculated at 320. Repetier Host has a nice little belt calculator under the Tools menu heading. You just enter in your motor step angle, which I'm using 0.9 degrees per step. You enter in what your driver microstepping is. I'm going to be using 1/32. Your belt size, which most common is 2mm GT2 belt, and I'm using 20-tooth pulleys. And then you click calculate, and that tells you your value for your steps per millimeter. Now the extruder, you need to adjust based on what type of extruder you're using. It's not going to be, even if you're using the same motors as your XYZ, it may not be the same depending on gear size, if it's using a gear ratio, reduction ratio. So you'll probably have to measure that. Then you can enter in your homing feed rate. Here you can adjust your stepper current, and you want to be close to what the motor is rated for. If your motors, that's a good place to start. So if your motors are rated for 1.6 amps, then enter in 1600 milliamps. And if it seems your motor's getting too warm, back it off a little bit by maybe 100 or 200 milliamp increments. If you're getting motor skipping, then your ampage probably isn't high enough, and you'll need to check this here. If you check dynamic current, your in current provided to the motors will automatically increase as the speed of the motor begins to increase. I haven't used it yet, so I can't comment on how well it works. Then here you set your micro stepping for your motors, XYZ, and your extruder. Retract and length and feed rate, I think, should be in your slicing profile and not here. So I suggest you enter more than what you want it to be, and then set it to where you want it in the slicing profile. Same with the retract, recover. Set your maximum acceleration and your acceleration here. Acceleration is how quickly your print nozzle gets up to speed when you're printing. So if you have it set for 50 millimeters per second, this determines how fast it reaches that in the amount of time it has before it has to change direction. If you have these values too high, you could lose steps. In your advanced variables, you can set your max XY jerk and your Z jerk. What that is how quickly it can change direction without causing anomalies in your prints. And then at the bottom you have your temperature PIDs. If you do your auto tune on your temperatures, you can enter the values in here, and I'll cover that in a separate video. Once you have all these values set into the way you like them, click confirm, and it'll save those values to your printer board. And then you also want to make sure you click save before you exit. And just to note as well, under your printer profiles, if you have multiple profiles, you can click this star to set which one you want as your default. Once you have your printer profile set up, you want to go to your connection here. You want to select the printer profile that you created and click connect, and then it should show your machine status here. And that's it for today. I'll cover more in upcoming videos. Thanks.